In this episode, we will discuss the theory of gravity, the source of much of the Fui in Fuiology. Dark matter, dark energy, potential energy are all things created by physicists to compensate for the failure of the theory of gravity. Black holes are a result of the theory of gravity, but they only exist between the ears of physicists. At first glance, the theory of gravity makes perfect sense. An object falls because a force is pulling it towards the center of the Earth. The planets orbit the Sun because a force is pulling them towards their Sun as their momentum is carrying them away. But when you get into the specifics of gravity, it makes no sense at all. If this is the Earth, this is the Moon, and this is the Sun, why is there a high tide on this side of the Earth? All the gravitational force is pulling in this direction. You would expect there to be a low tide on this side of the Earth. Why doesn't the Sun cause a high tide on the daylight side of the Earth? It is pulling on the Earth with a force greater than that of the Moon. You would expect it to also cause a tide. But the only tide is when it's in conjunction with the Moon. Why is the Moon in orbit around the Earth at all? If you calculate the force of gravity between the Moon and the Sun, it is 60% greater than the force of gravity between the Earth and the Moon. This would mean that when the Moon is in this position, the Sun is pulling on it with a 0.5% greater force than it is pulling on the Earth. This would move the Moon a little bit further this direction than the Earth. When the Moon is in this position, the Sun is pulling on it with a 0.5% less force than it is pulling on the Earth. This would mean that the Earth is moving a little bit closer to the Sun than the Moon. Every month, the orbit of the Moon should expand a little, and after billions of years, it should have been pulled completely away from the Earth. The dynamics of how the gravity works also causes a problem. When the Sun radiates light, it decreases in distance from the Sun at a constant rate. This means that the intensity of light is just a matter of the distance you are from the Sun. But this is not the case with gravity. For every object in orbit around the Sun, there is a different gravitational force. There is no constant force that decreases according to distance. If you were to think of the force of gravity as a stream of water that is holding the planets away from the Sun instead of pulling them towards it, for Mercury, which is a small planet close to the Sun, there would be a small stream of water at low pressure forcing it away from the Sun. For Jupiter, a huge planet far from the Sun, there would be a huge stream of water headed towards Jupiter at high pressure. Why is Mercury, as it orbits the Sun, unaffected when it passes through this stream of huge force headed towards Jupiter? Why, when the Moon is on the far side of the Earth, is the Sun eclipsed, but the force of gravity is completely unaffected? This would mean that the Moon is pulling on the Earth and the Sun with two different gravitational forces, traveling in the same direction, but the force between the Sun and the Moon is unaffected by the Earth being in between it. When it comes to the energy of gravity, there's also problems. When an object falls off a cliff, it gathers in kinetic energy until it hits the ground. Where does this energy come from? According to scientists, there is potential energy, which is stored in the mass of the rock until it starts to fall off the cliff. By an unknown means, this mass is converted into kinetic energy, explaining the energy of the object when it hits the Earth. This would mean that for every asteroid in orbit around the Sun, there is a little bit of mass containing the potential energy that would be released if it hit the Earth. As the asteroids in the Earth orbited the Sun, this potential energy and mass would be constantly changing. Since an asteroid could also hit the Moon, Mars, Venus, Mercury, or Jupiter, there would also have to be mass storing the potential energy for these collisions. As an asteroid moved towards the Earth, converting mass into kinetic energy, would its mass decrease or would it increase because the potential energy between it and Jupiter is increasing? This doesn't make any sense at all. When it comes to how the force of gravity uses energy, there is also no sense. The Moon and the Earth pull on each other for an entire month, doing work as the Moon moves around the Earth. At the end of the month, The moon and the earth are in the same relative position with the same energy. Where did the energy come from? Where did it go? This 100% efficiency of some sort of energy violates the laws of thermodynamics. When Newton postulated the theory of gravity, he made an assumption that an object in motion would continue in a straight line unless another force acted upon it. Well, nothing travels in a straight line, not even light. So we will change this assumption. We will say that an object in motion will maintain its energy unless energy is added to it or given off by it. We will also say that energy is a thing. It is not another form of mass. It is not a property of an object in motion. It is one of the fundamental building blocks of the universe. It and matter combine to make objects. When energy is added to the neutron molecule, it creates the hydrogen atom, which has both an energy field, which we recognize as the magnetic field, and an electrical field, which comes from the matter. Energy fields can combine to form larger and larger objects. An object in the energy field of another object will tend to equalize its energy with the field in which it exists. If you were to take the velocity of a planet squared times the distance from the sun, you would get the same value for all of the planets. This represents the energy of the solar system, which is centered in the sun. The planets do not orbit the sun because they are being pulled towards it, but because they are in equilibrium with the field around it. If the planet were to move away from the sun, it must release energy. If it was to move towards the sun, it must gain energy, and it can do neither of these while it is in equilibrium with the field. The use of energy fields would explain why there's a high tide on the far side of the Earth. The moon and the Earth's energy field combine, increasing the energy field on the far side of the Earth. The water, then trying to equalize with that field, falls up to create a high tide. The sun does not create a high tide because it is not pulling on the Earth or the moon. Their combined energy field is in equilibrium with the field around the sun. This equalization of an object with its energy field would explain one of the peculiarities of orbit dynamics. If you have a satellite in orbit around the Earth and you want to increase its velocity, you step on the brakes. This causes the satellite to lose energy, move into a denser energy field, and end up with more energy than when it started. If you want to slow a satellite down, you step on the gas. This again makes it so it is no longer in equilibrium with the field, causing it to move into a weaker energy field, giving off energy, causing it to end up going slower or with less energy than when it started. This would also explain why the mass of a satellite makes no difference to the speed. The speed of a satellite is strictly controlled by the distance it is from the Earth. It seems rather odd that the mass of a satellite, which controls the force, is irrelevant when it comes to the speed of the satellite. By using energy fields, the combining of energy fields, and the equalization with an object in an energy field, we can explain why things orbit, why things fall, why there's a high tide on the far side of the Earth, and how the energy of gravity actually works. There is no reason to create dark energy or dark matter to explain how the universe is held together. There is no need to create potential energy to explain the energy of falling objects. The use of energy fields make it far simpler than a theory of gravity when explaining how planets orbit and how things fall. In the next episode, we will discuss how matter and energy combine to form the atom, the nature of light, and how chemical covalent bonds are formed.